In this section, we'll be solving word problems. Now, we should already have an idea about how to translate an expression or a word problem into an equation. Now we want to take it a step further and actually solve for the variable in the equation. So let's do a few of these to get a good grip on it. Let's say the first one is, let's say 6. We have 6 times a number. 6 times a number is 24. Okay, the first thing we want to do is pick out some keywords. We want to identify keywords here. And the first one that jumps out to me is is. Is equals is equals. Is 24. So whatever we have on this side of the equation equals 24. That's the easiest one. Now we have a number here. The number is what we want to solve for. And it's an unknown, so we want to label this a number. Let's go ahead and label it x. X is probably the most used variable. There's nothing special about it, but it's just a placeholder, and we're going to solve for that in a second. So we have 6 times a number. Now, times a number means we're multiplying 6 and the number. Well, our number is x, so 6 times x is 24. Or 6 times a number equals 24. Excuse me. Okay, so when we're solving for a variable, we're solving an equation, the first thing we want to do is isolate our variable on one side and put everything else on the other side. Well, here we have a 6 attached to it. Our variable x is being multiplied by 6. So how do we undo multiplication? Well, you probably guessed it. We undo multiplication by division. So if we want to get rid of this 6, this multiplication of 6, we divide by 6. And the multiplication and division cancel out the 6's. Now, in order to keep the equation balanced, in order for this equal sign to hold true, whatever we do on one side, we have to do on the other side of the equation. So if we divide by 6 over here, we have to divide by 6 over here. All that's left over here after the 6's cancel out is x. Then we have equals. Now on this side, we have 24 divided by 6, which is 4. So x, our number, equals 4. Now, a really important thing that we want to get in the habit of doing is checking our answer. And what I mean by checking our answer is we want to know if this x equals 4 that we're supposing actually is a valid answer. And how we check our answer is everywhere that we see x in our original equation, our 6x equals 24, we want to plug in 4 for x and see if it holds true. So let's go ahead and do that. So we have 6 times x. We have x, so we're plugging in 4 for x because we're supposing x equals 4. So 6 times 4 equals 24. That's in our original equation of 6x equals 24. Now, in evaluating algebraic expressions, whenever we were substituting in a value for a variable, we put it in parentheses. We're going to do the same thing in equations as well. So now we just need to solve this and see if it's true. 6 times 4 is 24. And we have an equals 24. 24 equals 24 is a true statement, so that means x equals 4 is a valid answer. So the cool thing about doing solving equations, is that we should never get one wrong, because we can always check our answer. We can always plug in our answer into our original equation, and if it holds true, then we know we're correct. So let's get in the habit of checking our equations. All right, let's go ahead and move on to a next one now. Let's say Paul is twice as old as he was 8 years ago, and we want to know Paul's current age. Well, let's define a variable x. We're going to let x equal Paul's age, Paul's current age, to be a little more specific. And we want to know how old is Paul if he's twice as old as he was 8 years ago. Okay, so let's start with 8 years ago. Let's see how we can put that in numerical form. If you're 30 years old and you want to know how old you were 8 years ago, what do? Well, you subtract your current age, or you subtract 8 from your current age. So if Paul's current age is x, we're going to subtract 8 from it. Okay, so if he's twice as old as he was 8 years ago, this is going to give us our current age, and it's going to equal x, which is his current age. Now, if we want to know how old he was, if we want to know twice as how old he was 8 years ago, we're going to multiply this 8 years ago expression by 2, because he's twice as old as he was 8 years ago. So Paul is our x, and twice how old he was 8 years ago is our 2 times this expression. So now we have an equation that we can work with. And what we want to do is we want to isolate our variable and get everything on the other side. So the first step is we're going to distribute this 2 into the expression. If you need a little practice on this, go ahead and review the video on distributive property, and it's a quick refresher on it. 2 times x is 2x. 2 times a minus 8 is minus 16. Then we have x on the other side. Let's go ahead and we have a 1x over here. This is an understood 1x. So we have a positive 1x. So how do you think we're going to cancel this one out? Well, we're going to subtract a 1x. Positive 1x and a negative 1x cancel each other out. And whatever we do on one side, we have to do on the other side. So let's subtract a 1x over here. 2x minus 1x is 1x, or just x, minus 16, and then we have 0 on the other side. Almost done here. Now we just need to get rid of this minus 16. We need to move it over to the other side, essentially. So we have a minus 16, so we can cancel this out by adding 16. Plus 16 and minus 16 cancel each other out, and we have to do the same thing on the other side, plus 16. So the balance of the equation is still in effect. This canceled out, so we only have x on this side. 0 plus 16 is 16. So x equals 16. Paul's current age is 16. Now we don't want to forget to check our answer. We're going to check our answer by plugging in to our original equation 16 for x. Everywhere we see x. We actually have 2 places here. So let's do it. We have 2 times x, which is 16, minus 8 equals x, which is 16. Be sure to put our substitution in parentheses, so just for some added clarity. And then we can solve this, and if it holds true, then that means our answer is correct. So let's go ahead. Let's take care of what's inside the parentheses first, since we have 2 numbers and not just a variable and a number. 16 minus 8 is 8. We have 16 on the other side. 2 times 8 is 16. We still have 16 equals 16 on the other side. 16 equals 16 is a true statement, so x equals 16 is a correct answer. It's a valid answer. Again, we should never get an equation wrong if we can always check our answer. Let's do one more. Let's say the price of a computer decreased by, let's say, by 10%. So the price of a computer decreased by 10% in the past year. This year's price, the current price is $300. And we must be talking about a desktop, because you can't get a laptop for $300 these days. What was the price last year? Okay, so let's define a variable. Let's say, well, we're gonna let P for our price equal the current computer price, or actually the last year's computer price. We know our current, we want to find out last year's computer price. That's what we want to solve for. So we want to write an equation for this. Well, the computer price is going to be, well, the price decreased by 10%. So the price of the computer is going to be multiplied by a decrease of 10%. So we have, it's going to actually be 1 minus 0.10. This is the decimal form of 10%. 1 minus 0.10 times the last year's price gives us the current price, which is 300. Our current price is 300, and 300 equals last year's price times 1 minus 10%. Okay, which this is actually just 90%. So 90% of last year's price is $300, which is the current price. Don't want to confuse you here, but this is how we come up with our equation. Now we're going to isolate P and everything else on the other side. So let's go ahead and take care of what side in the parentheses. 1 minus 0.1, we already said, is 0.9 equals 300. And the way we write this, we always put the number in front of the variable. This is also called a coefficient. So 0.9p equals 300. Now we want to isolate p. We want to find last year's computer price. This is last year's price. So how do we do this? Well, we have our variables being multiplied by 0.9, and we saw over here that when we're multiplying something by a variable, we simply undo that by dividing by the coefficient. So we divide by 0.9. And whatever we do on one side, we have to balance it by the equation by doing it on the other side. So divide 300 by 0.9. These two cancel. All we have left is p on this side. And then 300 divided by 0.9 is $333. Okay? All right, so what did we learn here? In an equation, we want to recognize some key words in the word problem to write out an equation that we can reuse over and over for different values of our variable. Okay? And we simply keep the equation balanced by applying arithmetic operations on one side and doing the same on the other side to manipulate it in order to get our variable isolated on one side and everything else on the other side. I'll leave you to check this one in your notes, and I'll see you soon.